Ever hear the expression, "A picture is worth 1,000 words"? It's usually meant to apply to pictures of people or events, but it's also true for drawings made by architects and engineers. They use such pictures to plan and communicate specifications for giant skyscrapers, inside and out, down to the smallest detail. In this class, students learn mechanical drawing, a special type of drawing that conveys precise information.
We have windows and a door.
And then, construction workers, electricians, plumbers, and others look at these drawings and follow their instructions to make the plans a reality. So accuracy is essential in drafting. If a line is a bit too short or an angle is a tad off, the consequences could be undesirable or costly to fix, if not more severe. These students are learning the basics of mechanical drawing, geometric constructions. These simple skills will help students understand the way engineering works, so that someday they may design buildings, bridges, and cars themselves. Now, let's learn how to construct and bisect some geometrical figures using only the basic tools of a straight edge and a compass. Carla is going to copy the triangle ABC, and she only needs a straight edge and a compass to do it. Carla can set a distance on the compass and draw arcs with that distance from a point. She can use the straight edge to draw straight lines. That's all she needs. Watch. First, Carla draws a line that will serve as one side of her new triangle. Then she puts a point on the line that will be the vertex of one of the new angles and labels the point B. Using the compass, she measures the base of triangle ABC. That's line segment BC. Keeping that measurement, she puts the point of the compass on her point B and draws an arc through her line. Where the arc intersects the line, she puts a point and labels it C. Carla has made a new line segment BC that is the same length as the segment BC of the original triangle. Now Carla goes back to the original triangle to copy the distance between B and A. Moving her compass back to point B, she uses that measurement to draw an arc for the distance from point B to point A. Next, Carla measures line segment CA on the original triangle. Then she puts the point of her compass on the new point C and draws a new arc that intersects the previous arc for point A. Carla labels the point where the two arcs intersect, A. Now Carla connects point C to point A and point B to point A with her straight edge to complete her new triangle. Carla's new triangle is congruent to the original triangle ABC because Carla constructed that triangle with the same lengths of sides. Yep, they're the same. Suppose you've got an angle drawn, and now you need to cut it in half using only a straight edge and a compass. An angle bisector is a ray that will split your angle into two smaller congruent or equal angles. Using his trusty compass and straight edge, Chuck will show us how to draw an angle bisector bisecting angle A. First, he sets his compass to a distance shorter than the drawn parts of the sides of his angle. Then, placing the point of his compass on point A, Chuck draws an arc through the two lines forming its sides. Next, he labels the intersection points B and C. Now, using the same compass setting, Chuck places the point of his compass on point B and draws an arc. Using the same setting, he places the point of the compass on point C and draws another arc intersecting the one he just drew. Where these two arcs intersect, Chuck makes a point and labels it D. Then, using his straight edge, Chuck draws a line connecting points A and D. AD is the bisector of angle A. Let's see how this makes sense. Triangles ABD and ACD are congruent because they share side AD, and all the other sides are equal to each other in length because they were made with lengths from the same compass setting. Since congruent triangles have equal angles, angle DAB is equal in measure to angle DAC, meaning the original angle was cut exactly in half. Ever make a line drawing and need to divide one of the lines in half or bisect it? Using only a straight edge and a compass, you can easily construct a perpendicular bisector, a line that goes right through the other segment's midpoint at right angles. Stephen will show us how to make a perpendicular bisector of a line segment using a straight edge and a compass. Stephen's task is to bisect a line segment with endpoints labeled A and B. He adjusts the compass to any length greater than half of the length of AB. Placing the point of his compass on one endpoint, Stephen draws an arc through the line extending above and below it. Using the same setting, Stephen puts the point of the compass on the other endpoint and draws another arc through his line, long enough to intersect the first arc. The two arcs intersect at one point above and one point below the line. Stephen labels these points C and D and uses his straight edge to draw a line between points C and D. Line CD is the perpendicular bisector of line AB. You can see how this makes sense. The four triangles made by connecting the lines are all congruent. Sides AC, AD, BC, and BD are all the same length because you used the same setting on the compass to determine their lengths. The larger triangles are pairs of congruent isosceles triangles, so the four smaller triangles share equal angles. They also share common sides. If you call the point where the new line crosses the line segment M, then the length of AM equals the length of MB. M is in the middle, and all four angles around M are equal right angles. CD is perpendicular to AB, a perpendicular bisector.
Yeah.
Good job, Stephen. Stephen, Carla, and Chuck are now pros at basic geometric constructions. Congratulations!